Our first question deals with the principles of three-point bending and the type of crack that forms as a result. Three-point bending is a method of determining different mechanical properties of a material. The specimen is placed on two supporting pins while a gradually increasing force presses down on the middle. Data collected can then be used to find modulus of elasticity, flexural stress, and flexural strain. As the force continues, the bone starts to exhibit two types of loading: compression and tension. Compression occurs when the bone is getting pushed together, so on top, while tension occurs on the bottom where the bone is being stretched. In general, bone is better at resisting compression than tension because the tension perpendicular to the applied load causes failure due to Poisson's ratio. This means the fracture toughness is higher in compression than in tension. This causes a crack to start to form on the underside of the bone. The crack then continues up the bone, resulting in a transverse fracture perpendicular to the shaft of the bone. As a result, we can eliminate answer choice 1 due to the fact we know the crack does not start at the pins. We can eliminate choice 5 as well since we know both tension and compression exist. Then our knowledge of biomechanics tells us bone is stronger in compression, leading us to eliminate choices 3 and 4. Thus, we are left with number 2 as our correct answer. Our second question deals with how bone's nature and composition causes it to respond differently to different types of forces. In general, bones witness four types of loading: compression, torsion, tension, and shear. Compression is when bone is being pushed together, tension is when it's being stretched, torsion is when the bone is twisted, and shear is when forces act in opposite directions. Additionally, shear refers to when the force vector acts parallel to the cross-sectional area, while normal refers to when the force is perpendicular to the cross-sectional area. Due to the anisotropic nature of bone, the direction of the loading force dictates the strength and stiffness of the bone. In general, the bone is stronger when the load is applied in the longitudinal direction, such as loads like tension and compression. This is due to the composition of the bone, such as the way osteons are oriented, and the fact bone is used to receiving loads in this direction. Shear, on the other hand, acts in the axial direction perpendicular to the shaft of the bone. Thus, we can eliminate choice 1 and 2. We can also eliminate 3 and 4 since they are not typical types of loads bones witness. As a result, we are left with the correct answer being number 5, shear. A good way to think about this is chalk. Is it easier to break chalk by pulling on it, squeezing it, or bending it?